Hello students, welcome to lesson 9, chapter 11, 3-dimensional geometry, second PUC. We have been studying planes, equation of the planes we have started. Let us continue in this lesson with the equation of the plane. See, the case 1, we have already derived the equation. Consider a plane and O is the origin, and then first draw the perpendicular from origin to the plane, say OP. Suppose the distance from origin to the point P is small d, and suppose n is the unit normal, that is n cap is the unit normal along OP, or it is perpendicular to the plane. Then the equation of the plane is r dot n cap equal to d. This is the first case, that is equation of the plane when the distance from origin is given, that is d, and the unit normal is given. Then the equation is r dot n equal to d, or r dot n cap, that is n cap means unit vector. Now case 2, this is the case. Consider a plane, then A is the point, say whose position vector is A, and n is the unit, it is not unit normal, it is the normal. So that is the difference. You see, n cap means unit normal. Here capital N is given, that is n vector, which is a normal vector to the plane. If this is given, then the equation of the plane is r minus a, that is vector r minus vector a dot vector n equal to 0. And case 3, we have seen, this is the case 3. Let us say point A is a point on the plane with vector, say position vector A, and point B is another point on the plane with position vector B, and C is another point on the plane with the position vector C. Then the equation of the plane is r minus a dot b minus a cross c minus a equal to 0. Of course, r is a vector and a, b, c are also vectors. Now we have completed the first part, that is r dot n cap equal to 0. Now let us take the second case. That is one point on the plane A whose position vector is A is given, and normal vector to the plane is given n. So this is the second case. Let us proceed. So case 2, equation of a plane perpendicular to a given vector and passing through a given point is given by this. The equation of the plane which is perpendicular to a vector n and passing through the given point x1, y1, z1 is given by r minus a dot n equal to 0, where a equal to vector a equal to x1i plus y1j plus z1k, that is the position vector of the point whose coordinate is x1, y1 and z1, that is coordinate values x1, y1 and z1. This is the given thing, and n can be taken as ai plus bj plus ck. Students, please note, you should be well aware of these symbols also. For example, vector small a means x1i plus y1j plus z1k, that means it is the point on the plane. And capital N vector is ai plus bj plus ck, means it is a vector whose ijk components are capital A, capital B and capital C. So this distinction you should have. Now its Cartesian equation is, so both we have to see, a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. One is vector form, another one is Cartesian form. Now let us try to understand the given theorem. See, here I am in the textbook, it is not given as a theorem, but I am giving you as a theorem so that it is very clear for you. This is how we have to prove the given statement. So this is the coordinate system with the x and y and z axis. Say this is the plane. So what is given here is n is the normal to the plane. So n is ai plus bj plus ck, that is given. And the second one is a point p x1, y1, z1 is given. that is the point on the plane. So whose position vector is A? So what is A? It is x1I plus y1j plus z1k. So this is a thing. And then equation of the plane is r minus a dot n equal to 0. R means vector r, a means vector a, n means vector. That you have to understand. So that is the meaning of this theorem. And the Cartesian form is a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. This is case 2. So let us prove the theorem first, then we shall work out the problems based on this theorem. See, the theorem already stated the equation of the plane which is perpendicular to vector n and passing through the given point x1, y1, z1 is r minus a dot n equal to 0, that is vector form. And if you take a as x1i plus y1j plus z1k and n as ai plus bj plus ck, then the Cartesian form is a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. Now let us prove. So this is the coordinate system given. O is the origin. Now consider a right angle coordinate system. Now this is the plane. So consider a plane as shown in the diagram. Now let us say n is the normal vector to the plane. So that is given, and let n be the normal vector to the plane, and let us say point P is the point on the plane whose coordinates are x1, y1 and z1. So P x1, y1 be a point on the plane. See, in proof, what you have to do is you draw the diagram and simultaneously you have to write the sentences also. Whatever you have taken as the assumption in the theorem, that you have to write step by step. So what is given here is the point is given on the plane. Now, when you join OP, that becomes the position vector. So A is the position vector. So now, therefore, OP will be equal to A. The vector OP, that is position vector, that will be equal to A. Now take any other point, say for example Q, X, Y, Z. So on the same plane. So right, let Q, X, Y, Z be any point on the plane other than P. So first join OQ. So then OQ equal to R. So let us say the position vector of the point Q which we have selected, that is R. So this is one thing. Now first what you do is join P and Q because they are on the same plane. Now PQ by definition will be equal to, what is the formula? It is position vector difference, that is end point minus initial point. So end point is R because position vector of OQ is R. So it is R minus A. This we have studied in vectors. Therefore vector PQ will be equal to R minus A. Remember, observe carefully, the vector PQ is on the plane, given plane. Now PQ vector which is on the plane is perpendicular to n because n is by definition unit normal, not unit normal, normal vector. So normal vector means it is perpendicular to the plane. When the vector is perpendicular to the plane, it is perpendicular to the vector contained by the plane also. Therefore PQ is perpendicular to n. Now therefore what should happen? If two vectors are perpendicular, what is the condition? So now PQ dot n should be equal to 0. Now substitute, that's all. That is, what is PQ now? R minus A. Therefore R minus A dot n equal to 0. This is the vector equation of the plane. So simple. The proof of the second one is very, very simple. So the vector form is R minus A dot n equal to 0. So this is the proof. Now let us consider Cartesian form. Remember, whenever a vector form is given, then we have to take Cartesian form also. Now we have A is equal to x1i plus y1j plus z1k. This we made it very clear. And n equal to ai plus bj plus ck. Now equation of the plane just now we have derived. Vector r minus vector a dot vector n equal to 0. Now what you have to do? Just substitute. What is R now? R means any point. Therefore, it is xi plus yj plus zk. Therefore, substitute. So, R is xi plus yj plus zk minus what is A? It is x1i plus y1j plus z1k dot ai plus bj plus ck, because n is ai plus bj plus ck. So this equal to 0. Simplify. So when you simplify, you can write x minus x1i plus y minus y1j plus z minus z1k, first bracket, dot ai plus bj plus ck, that will be equal to 0. Now dot product, you know the formula. Therefore when you simplify, you get I component x minus x1 into I component of the second vector. Similarly, y minus y1, that is j component, b is j component, therefore b into y minus 1. Similarly, c into z minus z1, that is k component, and that will be equal to 0. This is Cartesian form of the equation. So first one is vector form, second one is Cartesian form. This is the case 2. Let us take one illustrative example. Find the vector and Cartesian equation of the plane which passes through the point 5 to minus 4 and perpendicular to the line with direction ratio 2, 3 and minus 1. So this is the first example. Let us solve. See, consider this is the given plane. Now what is given is this point A is given, and second one is there is a vector whose direction ratio is given and that vector is perpendicular to the plane. So what is given here is, therefore this is the understanding. A equal to 5 to minus 4. Therefore what is vector A? So 5i plus 2j minus 4k. This is one thing given. Point on the plane. So whose position vector is A. Then what is n here? So n is now 2i plus 3j minus k. Students, please note, it is not unit vector. It is normal vector perpendicular to the plane. So these are the two things given. Now it is very simple. Equation of the plane in vector form is, what is the formula? Write it. R minus a dot n equal to 0. Substitute. So what is R? Xi plus yj plus zk minus what is A? Just see here, 5i plus 2j minus 4k dot, then n vector is 2i plus 3j minus k, and that should be equal to 0. Simplify. Of course this is vector form, you can keep as it is. One more step, you can simplify if you want. That means x and 5 etc. you can club together. That is also not necessary. Then what is the Cartesian form? So Cartesian form will be xi plus, first consider the vector form, that is xi plus yj plus zk minus 5i plus 2j minus 4k dot 2i plus 3j minus k equal to 0. This is the given vector form. Now simplify this. When you simplify, what happens? X minus 5 times I, y minus 2 times j plus z plus 4 times k, that will be the first vector, dot 2i plus 3j minus k, this equal to 0. Now once again, so 2 vector dot product, so just simplify. Therefore this will be 2 into x minus 5 plus 3 into y minus 2 minus 1 into z plus 4. This will be equal to 0. This itself is the Cartesian form. Of course you can also simplify this one if you want, or you can just write 2x plus 3y minus z equal to 0 on simplification. So this is, one is vector form, another one is Cartesian form. This is the first illustrative example of the equation of the plane. Now let us take exercise problem, exercise 11.3. Example number 5, up to 4 we have completed. A, there are actually two parts. Find the vector and Cartesian equation of the plane which passes through the point 1, 0, minus 2 and normal to the plane. Normal to the plane is I plus j plus k. That means the vector which is normal to the plane is I plus j minus k. So here once again let me explain what is given. Point A is given, whose position vector is A, and normal is given, whose coordinates, direction ratios are 1, 1 and minus 1. 1, 1 and minus 1. So now we have A equal to 1, 0, minus 2. Therefore, definitely A will be equal to 1 minus 2k, because J component is 0. So this is A. Then N is what? It is I plus J minus K, because that is the normal vector given. Now therefore, equation of the plane in vector form, that will be equal to R minus J dot N equal to 0. That is the formula. Substitute X plus Xi plus Yj plus Zk, that is R minus, what is A? A is I minus 2k dot I plus J minus K, that is equal to 0. This is the vector form. So now equation of the plane in Cartesian form, what you have to do? Just simplify. First you have to take xi plus yj plus zk minus I minus 2k dot I plus j minus k equal to 0. This is the first thing. Now simplify. X minus 1 I plus y minus 0 j plus z plus 2 k dot I plus j minus k equal to 0. Just substitution. Now this is actually dot product. Simplify further. So x minus 1 plus y, then minus 1 into z plus 2 equal to 0. This itself is the equation. You can also simplify one more step, or x plus y minus z equal to 3 is the last form. Therefore, one is vector form, another is Cartesian form. This is example 5 in the exercise. So thank you students for watching this video. In this lesson we have seen the second form of equation of plane, that is passing through one point whose position vector is given and perpendicular to a given vector, that is called normal vector. So this is second case. In the next class, let us derive the equation of the plane in the third form, that is 3-point formula actually. So hope you have subscribed to my channel. If not, please subscribe and share with your friends. Please watch all the lessons from the beginning, that is lesson number 1 to the next lesson in the same order, because I have planned the lesson in a logical way. Therefore, if you want to follow the lesson of 8th lesson, so up to 7th lesson you should follow clearly. And in each lesson, normally what I do now is I am just revising what we have done so far, so that there will be a connection. Then we are proceeding. Hope you appreciate this. Let us meet in the next lesson with the third form of equation. Till then, bye. Take care.